Good morning. Today we're going to take a look at ratios specifically as they apply to geometry figures and geometry problems. So let's get to it. All right, so we're going to start with ratios as they apply to triangles and specifically as they apply to similar triangles. So if you haven't taken a look at my video on similarity and the AA property of similarity, go take a look at that now. But otherwise, let's talk about a problem like this might be set up with the following. If BC is parallel to DE, and that one sentence gives us similarity. So let's take a look at how. Here's BC, here's DE. If those two lines are parallel, then we know that through corresponding angles, this angle would be congruent to that angle, or we could do the same over on this side with that transversal. And then we also know that this angle is congruent to itself, and it is in this little triangle, and it is in this big triangle. So by the AA postulate of similarity, we now know that the little triangle ABC is similar to the triangle ADE. And as soon as we've got similarity, that means we have proportional sides. So let's say the givens went on to say something like this. And BC equals 4, BD equals 6, and AB equals 3. Find DE. Well, the first thing I like to do is put any information from the givens onto my picture. So I do this. And I also like to label what I'm being asked to find with a variable because that allows me to go ahead and start to create equations. So now, here's where ratio comes into it. We know that in similarity, the ratio of one side in the smaller triangle to its corresponding side in the larger triangle will be the same ratio for any smaller side to its larger side. And then the other thing to remember is that ratio equals division. Whenever they say ratio, you can write it as 4 to x with the colon, but you can also write it as 4 over x division. And that's what's going to give us equations to set up. So let's go ahead and set that up. So small to big, 4 over x equals small to big, 3 over 3 plus 6. Now, this is a common mistake students make. They go 3 to 6. Well, 6 isn't the full side in the big triangle, so just take care. It's an easy slip up to make, so just be aware of it. Okay, so now I simplify that to, and I can simplify that to, and now here's the next thing to remember. Whenever you have fractions that are standing across an equal sign, the way to get through that is to cross multiply. So I'm going to multiply up those loops. I've kind of made a mess of that, but that was 4 times 3 and x times 1, and that equal sign is still there. And so that's how you kind of unwind two fractions standing across an equal sign. It's the exact same thing as multiplying both sides by x to get rid of the x on the bottom and multiplying both sides by 3 to get rid of the 3 on the bottom. It just does it all in one gorgeous step. And so here we are at the end of our problem, x equals 12. Now, while we're here, we have figured out that the side similarity ratio of these two triangles, small to big, is 1 over 3, right? That is the side ratio. And that means that that is also the perimeter ratio. Because if I add 3 things, each of which is in a 1 to 3 ratio, then the sums of those things will remain in a 1 to 3 ratio. So the similarity ratio of these two triangles is 1 to 3. The perimeter ratio of these two triangles is 1 to 3. And now they might ask you for the area ratio. Well, you may not have enough information to find the actual area because we don't have a height, but we have enough information to find the ratio. If the side ratios are in a 1 to 3, the height ratios will also be in a 1:3. And if we have a 1:3 ratio times a 1:3 ratio, right? Half base times height. Those halves will cancel out, but we'll still be left with 1/3 times 1/3, which means the area ratio equals 1/9. So the area ratio is always the square of the side ratio. And that is true for triangles, for squares and rectangles, for circles, and for regular polygons. The area ratio will be the square of the side ratio. Okay, good. Let's take a look at one more problem. All right, here I've given you two circles, and this time I've told you that the area of one circle is 3 pi and the area of the other circle is 27 pi. Now I want to know the radius ratio. All right, so if my area ratio is 3 pi over 27 pi, cancel those pi's, simplify 3 and 27. My area ratio is 1/9. Now I go in the other direction. So my radius ratio will be the square root of 1/9, square root of 1 over square root of 9. My radius ratio will be 1:3. And that's a whole lot easier than figuring out that my radius here is the square root of 3 and my radius here is 3 square root of 3 and dot, 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 dot. All right, so there's your first taste of ratios and how they apply to geometric figures. So a couple of important takeaways just to summarize. Ratio means division. Two fractions standing across each other with an equal sign is solved by cross multiplying. And the area ratio of two figures is the side or radius ratio squared and vice versa. All right, play with this stuff. Take a look at some of my other geometry videos. And as always, keep on mathing.